we
just
haven't done the second two.
V final equals V initial plus A.
Yeah, yes.
And it can just be AT. The only reason I write A delta T is because it is technically just a change in time.
Okay. So a speed skater moving across frictionless ice at 8.1 meters per second hits a 4.8 meter wide patch of rough ice. She slows steadily, then continues at 5.4 miles per second. What is her acceleration on the rough ice? How come it's not deceleration? Since she's slowing down.
Because acceleration is, like we want to say the word deceleration because she's slowing down. We usually think of acceleration meaning speeding up.
Yeah.
But in physics, the actual meaning of acceleration is any change in velocity or direction.
Okay.
So she is accelerating. It's a weird thing to think about, but she accelerates negatively.
Okay. So we don't have a graph to look at now, so we just plug this in. So her final is 5.4.
Right. So go ahead and try to plug it in and we'll see what happens. .1.
We don't have time though.
Right.
So how could we do that? Because we are trying to look for acceleration.
So this is you've only talked about this kinematic equation?
Yeah.
Okay. Because it's using one that you don't have yet.
But we'll probably talk about it tomorrow.
Yeah.
Because this isn't due till tomorrow at midnight.
Okay. So this one, you have x final equals x initial plus v initial t plus 1/2 at squared. So these two are really the only two that you have.
Okay. Okay, no, we did go over the second one.
Okay.
We did that, yeah.
So you can use these two, if you want, we can use these two to find,
T.
yeah, to find, well, we could use this one to find t. Oh, actually, no, we couldn't. We can use these two to find a and t simultaneously. It'd be a simultaneous equation.
Okay, how do you do that?
You'd plug it all in, and then you'd say your x final, it's a 4.8 meter. So it'd be 4.8 equals 0 plus 8.1 t plus 1/2 at squared. You don't know t or a. And then in this one you say 5.4 equals 8.1 plus at.
Yeah.
So now you have two equations and two unknowns.
Okay.
So you can solve for, let's say we solve for a.
Would you make t 0?
No, because t is talking about the time it took to cross that little rough patch. So you can solve for t, and you just say, well, 5.4 minus 8.1, what is that? 0.7. It's 2.7.
Yeah, negative 2.7.
Yeah, so negative 2.7 equals AT. And you can say, well, negative 2.7 over t equals a. And you take this and you plug it in right here.
Okay.
Then you'd have that whole equation just in terms of t.
Okay.
Which isn't that hard to solve really, because then you look at it and you'd have 4.8 equals 8.1 t plus 1/2. A is negative 2.7 over t times t squared. These cancel.
Yeah.
And then
1/2 times negative 2.7.
you have 4.8 equals 8.1 t.
Negative 1.35.
So minus 1.35 t.
So then 8.1, 9.45.
You want to subtract it,
yeah.
though, yeah.
6.7 t.
6.7 t.
0.71.
0.71 seconds.
Yeah.
And then we're not trying to find t ultimately. We actually
want
want
the
to find
acceleration.
acceleration.
Then you pick one of those equations and put it back in, right?
So you can just stick it back in right there.
Okay.
Negative 2.7 divided by 0.71.
Negative 3.79. And that would be her acceleration.
Yeah.
Even the negative?
Yeah. Yeah, so acceleration is just like velocity. It has a
So that
direction.
means it's slowing down.
Mm-hmm. So there's that way. Or let's see if this one is familiar to you, because you'll use this one a lot more. So V final squared equals V initial squared plus 2A change in S, or change in X, or Y.
Okay.
You ever seen this one?
No, we didn't go over that one.
Okay, so real quick, the calculus behind these ones.
Uh-huh.
Let's say you had A equals A.
Okay.
Seems kind of silly, but to get velocity from acceleration, you integrate, right?
Yes.
So you integrate A and you get V. That'd be
Mm-hmm.
V final equals, what do you get if you, A is just a constant.
Yeah.
So what do you get if you integrate A? Think about it like this. If you integrated 2, what do you get?
I think it's just 2, right?
It's 2t.
Yeah.
So this is the same as saying 2t to the 0.
Yeah.
So when you integrate, you increase the power, and you
Mhm.
divide by the new power. So then you'd have 2ut to the 1 over 1.
Okay. Yeah, and derivative's opposite of that.
Mhm. So this gives you a t.
Yes.
But what else do you know when you integrate? You have a plus,
Plus or minus. Or a plus C.
yeah, plus
Yes,
c.
Plus C.
And we talked about earlier how the plus c is just your initial. So this is plus v initial.
Yes. Okay, so.
So this one is right here.
Okay, so that's how you would get that.
Yep. Then you integrate again to get position, right?
Yes.
So then x final, what do you get if you're integrating in terms of t?
Mm-hmm. So it would be a T O. Yeah, because you would square it
Yeah.
over 2.
Yep. And this is a constant.
Mm-hmm. So it stays
And what do you add to it when you
Um,
integrate?
plus, or you add 1 over 1, right?
So it'd be a bi
Just
to
a
the
t.
t over 1
Yeah.
plus,
C.
yeah, which would be
And the x to the x final.
the x initial, yeah. So
Yeah,
then-
x initial. That's what I was saying.
This is the same equation.
Okay.
If you just rearrange it a little bit.
Mm-hmm.
So now you can see, oh yeah, if I have constant acceleration and I integrate it,
Yeah.
then I get this equation, and I integrate it to get this equation. So that's where those two come from.
Okay. So you can always find them if you just.
Yeah, if you don't remember them,
Mhm.
you'll see the pattern of integration there. But this one, all it is if you take one of these equations
Mm-hmm.
and solve for t,
Okay, and you can get that.
and then plug it into this,
Okay.
and then rearrange it. And we could do the algebra behind it, but we don't necessarily have to.
Yeah.
So you remember on the last problem how we found her time first,
Yes.
then we put it back in, and
Mm-hmm.
that's how we solve for acceleration. So you take these two equations and
Yeah.
you get this one.
Okay.
So now, let's try that problem using this third equation real fast.
Okay. So what is? Yeah. No. Keep going.
So what's your final velocity? Oh, you went on to the next problem. So it was
Yeah, well,
five.
I hit submit, so it went on for me.
Okay, so
So-
5.4.
Mm-hmm. And then her initial is 8.1. And then.
We're solving for A. We don't know it yet.
Mm-hmm.
What's her change in position?
Negative 3.8.
Well, actually,
Why
so.
4.8?
Oh, is it?
3.8?
Oh, no, so that's her acceleration.
Oh,
So
we
we'll
just-
find this answer.
Okay.
But she hits a 4.8. So that's saying that she was going along at constant speed, and then there's this patch of ice right here.
Mm-hmm.
It's 4.8 meters long.
Yeah.
And during that, she slows down at a constant speed, or constant acceleration until she hits here, and she
Yeah.
keeps going at that speed. So this is the change
Okay.
in position as she had that acceleration.
So we don't care about the